Welcome back. Today's video is on trigonometry. So trigonometry just means triangle measure. So we're going to be dealing with right triangles when we're dealing with our trigonometric ratios. A trigonometric ratio is just a ratio of the lengths of the sides of a right triangle. We could be talking about the legs, we could be talking about the hypotenuse. So we're going to be setting up some ratios. The most common ratios that we have are sine, cosine, and tangent. So if you notice, I have a picture here. We're going to be using this picture to describe sine, cosine, and tangent, and I have color coded it as well. So we have triangle ABC is our right triangle. The hypotenuse is in green. So anytime I use the hypotenuse in a ratio, I'm going to be highlighting it in green. And then I have, on the right hand side, I have the leg opposite of angle A. So you'll notice angle A is over here. This is the leg opposite of angle A, that's in pink. And then the leg adjacent to angle B, it's the one connected or adjacent to angle B, that's in yellow. And then down here at the bottom, I did the leg opposite of angle B, so we're going opposite of angle B, that's also in yellow. And then the leg adjacent to angle A, adjacent to A, is also in pink. So anything to do with angle A, I put in pink, angle B was in yellow, and then the hypotenuse is in green. Alright, so I have a little chart here for you. Move the camera down just a little bit, try to get all of that in at one time so you can see it. Alright, so we're looking here at our triangle. So we're going to start with sine of angle A and sine of angle B. So sine of angle A, that means we're going to take the measure of the leg opposite. Okay, so we're doing the opposite of angle A, this pink, and the measure of the hypotenuse, which is the green. Okay, so then that would be BC, segment BC, divided by segment AB. So our ratio is opposite over hypotenuse. Okay, then for sine of angle B, we're using the measure of the leg opposite of angle B, which is yellow. And then we're dividing it by the measure of the hypotenuse, which is still in green. So sine of angle B is AC, segment AC, divided by AB. So that is still opposite over hypotenuse. Okay, so then going on to cosine. Slide this up just a little bit here. Cosine of angle A, we're taking the measure of leg adjacent to angle A, so that's in pink. We want the one adjacent to angle A in pink. And then we're still using the hypotenuse here. So that's going to be AC divided by AB. AC divided by AB. For cosine of angle B, we're taking the measure of the leg adjacent to angle B, so we're going to be over on this side. We want the one adjacent to angle B, and still the hypotenuse. So it's going to be BC over AB. BC divided by AB. Okay, and then the last piece is tangent. So to do tangent of angle A, we're taking the measure of the leg opposite of angle A divided by the leg adjacent to angle A. So both of our pinks. So if you look up here, we're taking the opposite over the adjacent side. So that's going to be BC divided by AC. Okay, so I'm going to slide back up here. So that was BC divided by AC. And then the last one is the tangent of angle B. So that's the measure of the leg opposite of angle B divided by the measure of the leg adjacent to angle B. So if we go back up to our picture, this time we're doing opposite of angle B would be AC, and adjacent would be BC. So it's AC divided by BC, or opposite over adjacent. Okay, so you should have that chart written down in your composition book, and now we're going to do a few examples of that. Alright, so here's our example. I have my triangle over here is my right triangle. It's STR. The measure for ST is 4, TR is 3, and SR is 5. Our right angle is at angle T. So that means 5 is our hypotenuse. Okay? Alright, so we're going to be finding sine of R, cosine of R, tangent of R, sine of S, cosine of S, and tangent of S. And for each one of these, we're going to express the ratio as a fraction and as a decimal. Fraction and a decimal. Okay, so let's go ahead and get started with that. So we're going to be setting up our ratios for angle R to begin with. So we're looking at sine of angle R. So if you remember, sine meant opposite over hypotenuse. So I'm just going to write that down here. So I want opposite over hypotenuse. Opposite over hypotenuse. So we're looking at angle R. That's right here. So the side opposite of R is 4. So that equals 4 over the hypotenuse is 5. 4 over 5. So then that gives us a decimal of 0.8 or 8/10. Okay, so then the next one we're going to do cosine of R. The cosine of R, we're dealing with adjacent over hypotenuse, so I'm going to write that down here. So adjacent over hypotenuse. Looking at R again, the adjacent side, the one touching, the leg that's touching angle R, is 3. So 3 over the hypotenuse, which is 5. So 3 divided by 5, you can punch that in your calculator if you need to, that is 0.6 or 6/10. Okay, so then the next one that we have is tangent of R. So we're going to be looking at R again. Tangent is opposite over adjacent, so I'm just going to write that down here. Opposite divided by adjacent. Okay, my opposite side from R was 4. My adjacent leg was 3. So 4 over 3. So then that ends up being 1 and 1/3. We could also write that as 1.3 with the repeating bar over the 3. Okay? Great job with that. Let's go down to sine of S. So sine of S, I'm actually going to slide down so that you can't see the triangle, but you'll be able to see the work here. So sine of S. Sine of S, we're dealing with opposite over hypotenuse again. Opposite over hypotenuse. And what are those segments for opposite? So if you look back up at your triangle, the opposite side, looking at angle S, the opposite side, or the opposite leg, would be RT. So this is RT. Then the hypotenuse, that's labeled by SR. SR. So then what are the values of those? RT is 3. And SR is 5. SR is 5. So then when we change that to a decimal, that becomes 0.6 or 6/10. Let's go on to cosine now. Cosine, again, just like we had before, that's adjacent over hypotenuse. So adjacent over hypotenuse. And what are the segments that is adjacent to S? So looking at S, which one is adjacent? That would be ST. And then the segment that makes up the hypotenuse, that would be SR. SR. So what is the value of ST? ST is 4 and SR is 5. So then we punch that into our calculator if you need to. 4/5 would be the same as 0.8 or 8/10. Okay, now for tangent of S. So tangent, again, we're looking at opposite over adjacent. Opposite over adjacent. Now which segment is opposite of S? Well, we had opposite over here with sine. Opposite was over here with sine of S, and that was RT. And adjacent, we had here with cosine, we said adjacent was ST. And what are the number values for that? RT's value is 3. And ST's value, ST is 4. So 3 over 4. And then we change that to a decimal, which is 0.75 or 75 hundredths. If you notice, when you're looking at these, the cosine of R was 0.6 and the sine of R is 0.6. Those are equal to each other. Sine of R and cosine of S, those are also equal to each other. And then the tangents, those are inverses. We had 4/3, this one is 3/4. We just flipped those fractions over. Okay? Alright, that is actually going to be all for this part of the trigonometry videos, and I will have another video for you tomorrow. Have a great evening.